Hello everyone, welcome to Stereochemistry. Myself Halavat Ramesh, School of Chemistry, University of Hyderabad. Today we will talk about stereochemistry. Before going to discuss about stereochemistry, first of all you know that what is the basics of stereochemistry, right? So stereochemistry is a subdiscipline of chemistry involves the study of the relative spatial arrangement of atoms that form a structure of molecules and their manipulation. The study of stereochemistry focus on stereoisomers, which by definition have the same molecular formula and sequence of bonded atoms constitutions, but differ in the three-dimensional orientation of the atom in space. So, for this reason it is also known as 3D chemistry. So stereochemistry means is nothing but of a 3D chemistry. So stereo means three dimensionality, right? Is an important branch to stereochemistry is the study of optical means chiral molecules, the study of optical or chiral molecules. So now we will talk about stereoisomers, the molecules that have the same molecular formula and differ only in how their atoms are arranged in three-dimensional space. Stereoisomers is not equal to the constitutional isomers. So stereoisomers are different and constitutional isomers are different. Have the same molecular formula but differ in the way their atoms are connected, right? You can see now stereoisomers, right? Stereoisomers are mainly two types: geometrical isomers and optical isomers. Again, geometrical isomers means nothing but of cis and trans isomers, right? So optical isomer means isomer that contain an asymmetric center, that is called optical isomers, right? So geometrical isomers again cis and trans isomers, and optical isomers again mainly two types: enantiomers and diastomers, right? Enantiomers means nothing but of which have the mirror image relationship, that is called enantiomers, and diastomers means they don't have a mirror image relationship, that is called diastomers. Now we'll come to the geometrical isomers. What is geometrical isomer means the spatial type of cis-trans isomers are called cis-trans isomers, are also called as geometrical isomers. So geometrical isomers means nothing but of cis-trans isomers, right? A type of stereoisomers resulting from a double bond or a ring structure. So that is called geometrical isomers. You can see the some example of geometrical isomers, right? So trans 2 butane, see CH3 are the opposite directions and hydrogen in opposite directions, right? So you can see that this hydrogen comes to that this CH3 and this is CH3, so opposite direction, so that is called trans 2 butane. Then coming to the cis 2 butane means the same side, this CH3 will same side to CH3 and this hydrogen will to the this and same side, so that's why it will call cis 2 butane. Then coming to that another one example of geometrical isomers, cis isomers. You can see carbon double bond and chlorine are same side and hydrogen are the same side, so cis isomers. So the molecular formula, you can see that carbon double bond and chlorine are opposite direction, hydrogen in opposite direction. So the molecular formula is same, C2H2Cl2, and these molecules also H2C2Cl2. So you can see that this is the plane of molecules. Here also plane of molecules are same, right? The structure connectivity also same, the structure of the connectivity also same, but the relative functional groups, relative functional means nothing but of chlorine and the hydrogen, the relative functional groups are the different, that is orientation group. That's why it shows the cis and trans isomers. So geometrical isomers in a square planar, you can go to the coordination or inorganic chemistry, you can see the metal ligand complex, right? In that metal ligand complex, you can see here geometrical isomers in a square planar complex, right? So you can see that metal bounded with 4 atoms like A, B. So A are the same side and B are the same side cis. You can see that A and B are different. Here A to B different. That is trans isomer. You can look at another one example of cis isomers and trans isomers here. So H3Ns, ammonia and chlorine, right? And here is ammonia in the same side and chlorine are same side, right? Cis isomers. And this is NH3 to chlorine, and here is the chlorine. So opposite direction, that's why it is called trans isomers, right? From that I can conclude today that this topic you learn that what is stereoisomers and types of stereoisomers, geometrical isomers and optical isomers. And then next class we will talk about about the optical isomers, means what is what is enantiomers, what is diastomers, and its examples. If you like this video, please click on like button and subscribe. Thank you to everyone.